Good morning, everyone. Yeah, that's better. How many of you were in my talks yesterday? All right, so the Swedish crowd, and this is confirmed by yourselves, Swedish, is not very well known for speaking out in public or asking questions. So I had it all figured out today. I had about 30 tickets for beer to hand out for every question answered. And they said to me, I'm not allowed to do that. So I'm sorry about that. So please forgive me, but please do ask questions. Anyway, we're going to see an introduction to Node. This is what's all the Node about. And how many of you have actually seen anything to do with Node that was not in my session yesterday? Okay, so if you're new to Node, or I mean if you've already been playing with Node, you might pick up a couple of things here. If you're an expert in Node, you know, there's not much in here for you. You're free to walk out at this moment in time. After this, you're not allowed to walk out. You're meant to stay here. If you do walk out, please leave your name with me. No hard feelings. I'm just, you know, I want to chat to you later. Okay, so my name is Hadi. I'm a technical evangelist at a company called JetBrains, which I hope everyone's heard of. Everyone uses here ReSharper, right? Yes? Yeah, good. Okay, we do other tools as well. We're not the ReSharper people. We actually have like 15 tools. Okay, and we're going to see today a session to evaluate Node. And I'll tell you why Node and why the interest in Node suddenly. And hopefully you'll leave here not knowing anything. No, hopefully you'll leave here knowing enough about what Node is to see if it fits in, if it spikes your interest, if it's completely crazy nonsense talk, and you know, make up your own mind. JavaScript developers, how many? Right, keep your hands up. Keep your hands up all through the session. No. How many of you like JavaScript? Okay, that's good. That's nice. That's nice. How many of you hate JavaScript with a vengeance? Okay, good. So Node is an event-driven asynchronous I/O server-side JavaScript library written in C. Great. Right, we're done. Let's move on. It's open source. It was written by a guy called Ryan Dow in 2009, and it's currently sponsored by a company where he works at, which is called Joyent. But it's also sponsored by Microsoft. Otherwise, it would make very little sense for me to be at TechDays talking to you about Node if it was not anything at all related to Microsoft. It is built on V8, which is the Chrome engine for JavaScript, which is a very fast JavaScript interpreter. And what it does, it actually doesn't interpret it. It translates information, JavaScript, from JavaScript to native machine code. So Node is built on top of that. Now, JavaScript has normally been known for what? I will insist with my questions. JavaScript has normally been known for working client-side. Yes, we have our browser and we do things on the client side. You know that other thing you use that's called jQuery? How many of you use jQuery? Right, that is actually JavaScript under the covers, although many don't want to admit it because they hate JavaScript. But that is jQuery, that is JavaScript. And we've been using JavaScript to do client-side development on the browser. You know, move things around, do blinking little things, etc. What Node is JavaScript on the server. Okay? With the idea, the fallacy of, well, it's best to have the same code base everywhere. Right? You know how the Silverlight promise was you can write C# on the client because you're writing C# on the server? And a lot of the anti-Silverlight people were saying that's nonsense. You don't need to share the same language on the client and on the server. They're for different purposes. Well, a lot of those are now saying, oh, well, now you can share JavaScript on the client and on the server. Okay? So it's always two sides to every story. Why Node? Why this JavaScript on the server and why Node? Well, what is the most intensive operation you have when you're developing applications? I'll give you a hint. It's on the slide. It's I/O, right? It's talking to the database, it's talking to the file server, it's talking to directories, it's talking to another service. The input-output is the most expensive thing of any application. And yet we find developers constantly saying, oh no, I can't make 5 methods because the call stack there is going to be really unoptimized. But your bottleneck is normally the database and other things. Now, the way that we attack that when we're doing kind of web development or highly scalable websites, because all of us here do write the next Facebook, what we do is we have a server that accepts requests based on threads and then fires off these different requests, handles them. Now in ASP.NET, those number of threads that a server can accept are limited. So once it reaches that limit, it cannot handle any more requests. And these threads are off working on I/O, waiting on I/O, waiting for operations to complete to then come back and process the next request. Okay? That has in its problems, on top of the fact that it is limited, threading has other issues. Like I was seeing on Twitter yesterday, it's a famous tweet, like if you have any problem, you know, solve it with threads and now you've got a much bigger serious problem. The idea behind Node is it's based on this mechanism of an event loop, right? So basically the idea is that I have an event loop which is single threaded, and it's not exactly, but it's single threaded, and this single thread is just going through and handling requests, and when a request comes in, it will fire it off and have some worker thread process that request, and when that worker thread, when that process has finished, it will call back into the main loop, and then I handle it, similar to how the event loop works in a Windows applications, etc. Okay, that's the idea behind it. So a lot of times people say, well, Node is single threaded. Yes, there is only one thread that is going through this event loop processing your request. However, in the background there are worker threads. But the way that Node does it is much more efficient than the way that we could ever do it. And also, it frees us from having to work with threads, from having to worry about thread synchronization, from having to worry about data synchronization, etc. Because when our processes are finished, they will execute sequentially on a single threaded loop. What benefits does this provide us? This is two web servers. One of them is Nginx, which follows the same event loop model, and the other one is Apache. And you can see that as the number of concurrent connections increases, the number of requests per second decrease with Apache. Versus with Nginx, it kind of still follows a normal pattern. It decreases a little bit, but then more or less remains steady. And that's in terms of requests per second and concurrent connections. If you look at memory consumption, this is another big issue. With threads, there is a lot of memory overhead, unless we do it very, very efficiently. If we drop down to things like fibers and I/O port completion, which is what Node does under the covers. And you can see here that based on the number of connections, concurrent connections, again with Apache we see a great increase in the memory consumption, and versus with Nginx, we see a continuous, constant consumption. Okay. Now, I have, shown you two graphs, and I've said to you that this is about, solving the problem of I/O that is expensive and the scalability. How many of you here work at Facebook, or Twitter, or any similar company, or have web applications? How many of you do web applications? Good, that have over 1 million users accessing it concurrently. Only you? Okay. Over 100,000 users concurrently. 50,000. 10,000. 500. 50. You can do CGIs with that, right? So why are you here? You're obviously not here because you have scalability issues. You're here because all of the other sessions weren't interesting. No, you are here because you want to know about Node. The same way my interest was spiked by Node. It wasn't about the scalability. It was about finding different ways to do things. It was about seeing, because I was looking at examples and I was seeing that what takes me a lot of time often to do in C#, for instance, was much faster and simpler to do in Node. So for me, it was about the simplicity of Node, right? That simplicity is sometimes you have the trade-off of that you're working with JavaScript, so it's not that simple. But yet there are a lot of things that attracted me to Node about its simplicity. So don't look at this session as and discard it as saying, You know, I am not interested in scalable applications, so therefore this is of no interest to me. You don't have to only do scalable applications to use Node. Much like if any of you have worked with NoSQL, anyone here NoSQL databases, do you have highly scalable applications, or you're just tired of ORM mapping? With NoSQL databases, it's not that much about scalability always, but about not having to deal with the mappings. I could just take an object and dump it, right? Dump it in the sense of store it, and then recuperate that object. What Node offers us are two main advantages in terms as opposed to threading, which is it hides the thread programming. So we don't have to worry about any kind of thread programming or thread synchronization. And it intelligently handles those threads. And it does this in different ways. It uses a library in Linux, which on Unix systems, on Windows it uses I/O completion ports. So it drops down to a lower level than we could, but which we would want to if we were doing it ourselves. Supported platforms, pretty much all of them, right? There's a penguin in there as well missing. Cloud support, this is why we're here, okay? We're here because Microsoft now supports Node. In fact, it is no longer about .NET anymore in this world. If I go to Chrome and I go to Windows, Azure.com, develop, look at that. .NET, Node, Java, PHP, other, right? We have moved past .NET in the sense of, for Microsoft, it's not only about .NET anymore, right? With cloud computing, now you can host your .NET applications, your Java applications, your PHP applications, and your Node applications. So Microsoft offers support for Node. App Harbor, if any of you have heard of App Harbor, that provides support for Node. Nodejitsu provides support for Node, and Joyent provides support for Node. Joyent is the company that I mentioned that Ryan Dahl works with. These guys, these two, formed a partnership to offer Node on Windows, because up to now Node was only available on Unix-based systems. So with Microsoft they ported Node to Windows. Okay? That's your interest in Node, because now you have the availability. It would be of very little interest if the vast majority of us here are .NET developers, are Windows-focused developers, and if we want to run Node, we have to use a Mac or we have to use Unix systems. No, now it is open to you, much like .NET is. You want to host an ASP.NET MVC application, it's probably the exact same experience as hosting a Node application on cloud. Any of you actually have any cloud services hosting? Anyone? Node on Windows. As I said, it was a collaboration with Joyent, and what happened is that basically there was a library that they would use, and what they did, it was called libioc or something like that, and what they did was take that library that's used in Linux for offering high performance threading and abstract it away and write libuv, which is a multi-platform library. So Node sits on top of libuv, and what it does is that on Linux it has one implementation, on Windows it has another one. Okay, this is the one on Linux, and this one is the one on Windows, how it's implemented. How do I get started? How do I start working with Node? It's again very simple. It was harder before, now it's very easy. You just go to Node.js, nodejs.org, hit download, and select your installer, Windows or Macintosh. When you install Windows, what it also, well, on Macintosh as well, what it does is it installs another thing which is called NPM. What is NPM? That's the Node Package Manager. Have you heard of NuGet? Yes? That is NuGet for Node. And anything you can possibly think of is on here. I mean anything. If you have a microwave in the house and you want a library to talk to that microwave, it's on here. You don't believe me? Don't challenge me, because I don't know if it is. But it's like, I just don't get any reactions from you people, man. See, if I was in the US, someone would say, what brand of the microwave is that? Okay, so in terms of tooling, what can I do in terms of tooling? Because JavaScript has been known for I have to use a text editor to do JavaScript because there's no IntelliSense, there's no code completion, there's no refactoring. That's all nonsense, right? Especially if you're using a tool like ReSharper in Visual Studio, you have all of that. If you're not using that, there is alternatives. There's WebStorm, which is what I'm using here, which is a tool from us. There is Visual Studio without ReSharper, or you can use an alternative to ReSharper. There is Cloud9, which is a web-based IDE, and all of these have first-class support for Node. So that means that I get IntelliSense for Node. That means that it's aware of what Node is. It does completions, etc. Okay? I can do refactoring. I can do a whole bunch of things. So really start to consider JavaScript just another language. I know it's dynamic, but I always say it's not about static versus dynamic. It's about tooling versus non-tooling. Okay? So there are options. Don't let tooling hold you back. Node, when you install it, the first thing it does is install an executable, right? Which is a REPL, which is read, entry, and the print line. Basically what you type in there, it evaluates it. It's an evaluator and spits it back, okay? So I can now go to my terminal server here, and let's clear this guy up. And let's clear this guy up, okay? Let's go back to temp. And I can just do node, and that will prompt me with some prompt there. So this is JavaScript. I can write 2 + 2, give me 4. I can write console log ABC, and that will give me ABC. Okay? But Node is also a server in the sense that it can run scripts. So I'll exit here. You see that I have one here that's called abc.js, which does console hello. And if I do node abc, it will run that file. Now, that is not normally how Node would work. It wouldn't run a file and exit. The whole point of Node is to act like a server, so it's at some point waiting for something. Be that a request from a file, be that a request from an HTTP server, be that a request from a socket, etc. We'll get to that in a moment. Now that console, where did that come from, right? Console is actually a shortcut, an alias to another thing which is called process write. So process to Node is the same as the window object is to a JavaScript, to a browser. You know how window is basically the root object in a browser where you can access everything? Well, in Node, it's process. And what is process? Process is an object that gives you access to the actual process that's running and the underlying operating system. So from process, you can do things like get the CPUs, etc. But Node isn't only a server and a console where you can write things in and out. If you come to Node.js, click on docs, you can see that I have a bunch of objects, right? Not classes, objects. Let's hit, for example, HTTP. And here I have HTTP server, server request, clients, etc. Let's go back. I have a DNS. I have buffers and streams. So when you install Node, it comes with a whole bunch of objects which allow you to work with the operating system on the server. You can create sockets. You can talk to DNSs. You can create HTTP servers. You can create HTTP clients. You can create timers, buffers, streams, work with files, work with directories. I mean, there's even a file system here where I can rename files, create directories, delete files. So anything you could think of is there. And what is not there, those are the built-in objects that are in Node. What is not there is in the Node package manager.js.org. So it's like the equivalent, to put it in terms of .NET, it would be the equivalent of the .NET framework, right, with its base class library and all those utilities, and then NuGet. This would be Node with its all objects and utilities, and then we have NPM. Okay? So already out of the box, it ships with a whole bunch of what's called modules, built-in modules, that allow you to do a whole bunch of different things. Otherwise, it's not just an interpreter where you have to write JavaScript and write everything by hand. It already comes with a whole bunch of things, and we'll look at these. Okay? So let's get started with some demos. I think I have that open. Node.js. Any questions? Yes, I see someone half putting up their hand. Or were you just scratching your ear? So getting started. Here's a simple app which we saw. Hello world, right? So console.log is the equivalent of process.write. If I go over to the terminal here and I do node and I do process and hit tab, I get completion. And you see that I have all of the different methods that exist. Okay? And console is just a thingy for that. It's just a alias for it. So here's another one. This now, I'll show you what that util does in a moment. But what this is the equivalent of string.format in C#. Right? I do require util, which is a module. Then I do formatted string, util format, hello, welcome to demo number, people 2. So this is people, it's going to replace that. And this is a decimal number, it's going to be replaced by number 2. And then I do console log formatted string. Let's change here. cd Dropbox presentations and node code. Getting started. And I do node. What was it called? Util demo. Util demo. You see, hello people, welcome to demo number 2. Right? We also have the option to do self-executables. So, well, this is more on the Mac. You can do on the Linux. You can say that this script is using Node and then just write Node here. So this would be a kind of self-executable demo of Node. Okay? Here's one a little bit more complex. That's what that's doing, is reading a file from the disk. Right? So instead of util, now I require the file system, and I say file system read file sync, pass in the name of the file, pass in the encoding, and it returns to me the contents. And then what I'll do is log some header, log the contents, and log some footer. So I could do node reading file system, and it will read the file system for me. Pretty simple, right? Yes. Yes. We'll get that. We'll get to that. We'll get to that. I'm so excited. I have a question. Yes. So out of the box, we have these two things. We have global modules and we have modules that I just shown you. So global modules are global in that you don't actually have to request, you don't have to do a require. And I'll tell you what require actually does in a moment. And then there's modules that are not global and you would have to do a require, like I did for the file system or I did for the util. Okay? How do you know which one is which? You look at the documentation. There's over 30 modules provided, and as I said, whatever is not provided in Node are provided with other modules as NPM. So what exactly is modules? Well, you know that JavaScript is a language that doesn't have privates, it doesn't have classes, it doesn't have namespaces, right? So how do I kind of encapsulate functionality in different areas so as not to overlap, right? If I create an object called file system, Joe can create an object called file system. Which one does the user use? And not only that, we need to still organize code, even if it is JavaScript. But it doesn't provide any type of functionality for namespaces. However, there's an agreement which is called CommonJS, which is implementing a series of patterns to allow to overcome these issues. And one of those patterns is the module pattern to try and overcome the issue of not having namespaces. So what the require does, in fact, is actually it's the equivalent of importing a namespace to all practical effects. So when I do require something, the object that it returns to me are the objects that that file has exported. Okay? I won't go too deeply into how this works, but basically you can understand it as exactly the same as a using statement in C# for all practical effects. Okay? here I'll just show you some demos of the modules. You can create your own modules. So here is, for instance, my single function, right? And I use this object, this global object, which is called exports, and I say this module, this file, which is called my single function.js, will export a function which is called log message. And here is the definition of the function. Now, when I want to use this, I do my functions require the root to it, and then I do my functions log message. If I want to export multiple functions, I do my multiple functions, and you can see that here I'm actually giving the function a name, but then the value that I'm exporting can actually be different than the name I'm giving it, right? So I can say my first public function, but then the exported name would be function 1. How do I use that? I do require the same thing, and then my function, function 1, my function, function 2. My function, my private function, would not work, and you can see that WebID actually highlights that differently, saying it's unrecognized. Why wouldn't it work? Because I have not exported this. I have not added an export my private function. Practical effects for you, if you want to drill down deeper into how export works, that's fine, but takeaway is it's like namespaces. Okay? Writing code in Node, which is coming to your question now. The problem with Node, the problem with synchronous programming is that the advantage is that it's very clear to read, right? I read from top to down. I say, get me some information. If that information is not blank, then process it and store the result somewhere, okay? And then I go to the next line. So I would execute the input, I would execute the if, and then I would come here. Now, if my code is like that, the problem is that Node isn't going to add any value for me because it's going to process sequentially. And that's where the concept of callbacks come in, because synchronous code does not scale. So if I were to run this code, put this in a Node file, it would never exit. Why? Can someone tell me? The condition never changes. Now, this is obvious. However, if I were to take the same concept here and I were to put a long-running process as opposed to a process that never exits, this would take time to exit. So the whole program would block until this one has finished. What that means is that if I have this type of code in my application, then what will happen is that any other process, any other request that is coming in won't be able to be processed until this one completes. So I cannot write synchronous code in Node. I shouldn't write synchronous code in Node. And if you look at this method here, this file sync, reading file sync, you can see that it's called read file sync with the explicit word sync there, right? Because it's reading a file and it's returning the result. If you go to the documentation on Node, let's look at read file. You see over here we have read file, and then we have read file sync. This one is asynchronous. By default, everything in Node is asynchronous. So there isn't a read file async because read file is asynchronous. However, there is an explicit read file sync because it's telling you to be explicit about it, to know that when you're doing a read file sync, you are calling synchronous code. Okay? So how do I solve that? How do I prevent writing code like this? And that's where callbacks come in. That is the same concept, more or less, as asynchronous callbacks that we have in .NET, right? We have the begin request and the terminate request, and when the terminate request comes in, it will call back a function. It's the same concept. And basically what I do is I do object, do something, pass in the parameters, and then have a callback function. And when that do something has finished, it will call back this call me when done. And when that callback is called, then I will process the result. Okay? You're following me? Right. So, the benefit of this is that in JavaScript, we can combine callbacks with what are called closures, which JavaScript offers. and it allows us to access private fields that form a closure with the function that they're declared next to. Okay? So let's just see how we can do that same thing using read file async. This same example that I showed you, how would that be properly? See now that I don't have a return value. Now I'm doing read file, pass in the name, pass in the encoding, and then I pass in a function. And the function takes two parameters, an error and a contents. Okay? So what I do is I say if there's an error, throw the error. If not, then log the contents. So the actual result of the value, the actual result of the execution of that function would be in this section. Right? So if I run this guy, and do node read file async, you can see that it does the same result, but it's executed asynchronously. Okay? Now, instead of doing this thing here, I can start to make it a little bit nicer. Read file async named. Here I'm giving that function a name because what this one is an anonymous function. Right? It's a function that doesn't have a name. And the problem with having anonymous functions is that, first of all, it doesn't make the code very clear to read because it's not telling you what that callback is doing. Secondly, as you start to have call stacks pop up with exceptions, you don't know where exactly that's coming from. So it's recommended to give them names. There's a third alternative, which is to give it an explicit declaration to the function and then pass in the name of that function. Okay? The problem that happens here is that as you start to do more things with Node, you can have the result of the contents here now call another function, and that one call another function, and that one call another function, and that's what's called the pyramids in callbacks, because we start to have one callback inside another callback, inside another callback, inside another callback. Okay? There's ways to solve that. Central to Node is this concept of event emitter. It's an object that allows you to work with events. So everything in Node is around an event, right? If we are processing requests coming in from TCP socket, if we're processing requests coming from a web server, if we're processing requests coming in from a file change, all of this is evolved around events. And you can extend this, you can use this event emitter, and you can extend this event emitter with your own custom objects. Any of you have done any kind of DDD or event-driven architectures? Right? It's the same kind of thing here. So I'll show you two examples of this. Here's a simple event, okay? I require the module events, and I create an instance of this object, which is called the event emitter. And then I do on some event, call this callback function, and then I use emit to emit some event. And then I do emit some other event. Since that some other event isn't defined, it's not going to do anything. If you run this, we'll do node simple event, it will do some event was fired. But the thing is that whatever code comes here afterwards, it will stay, it will continue to execute. Okay? Here's another example where I'm inheriting from that event emitter. And the vast majority of the objects that are included in Node use this pattern. So the HTTP object is actually inheriting from an event emitter and waiting for TCP connections to port 80 or whatever port defined. Okay? So here I have a customer, and this is a utility that is provided with Node, which, because again in JavaScript there's no such thing as class inheritance because there's no classes, so you have to simulate object inheritance. So you can do util inherits customer and then the object that it's inheriting from. And what I do here is I define make preferred, and I say that when make preferred is called, set is preferred to true and emit the event made preferred. Now I use it. I say create a new instance of the customer object, on made preferred, console log customer was made preferred, and then I do customer make preferred. So what I'm doing there is actually invoking the make preferred, which will then set the is preferred to true and raise the event. So we'll do node custom object, and you see that customer was made preferred. Okay? This is how the vast majority of the objects inside Node work, using this event emitter that's built in. The bad loop here is that if I start to block things, then things won't happen. So here I do event emitter on raise, log event has been raised. Set timeout. So what this is going to do, this is a function in Node which allows you to wait 2 seconds and then execute a function. Right? So I say wait 2 seconds and then emit an event. And I'll do console log entering loop, and then I'll enter an endless loop. Can someone tell me what they think is going to happen there? The event is not going to fire. Oh man, thank God for that. It's like 15 pictures. I'm like, you get the picture already? Really breaks your concentration. Entering loop, and it'll never go. Right? Now, again, this is not ever going to be explicitly done. However, what this does raise is a question where you can get deadlocks. So if you have one event that is going to set a flag for another event to be raised, right, it can enter a deadlock. Okay, so you have to be aware of that. I'm just simulating this deadlock with an endless loop. Right, so if entering here and here I would do, set the raise the event or set a flag so that this is checking on a flag, you would have that issue of a deadlock. So I've just shown you basically nothing. Okay, are you excited at all? Wow, you're excited and I haven't shown you anything. That's good. Building something useful. HTTP, right? I told you that this comes with a series of classes. So one of them is an HTTP server. Let's go down here to HTTP, and that's the HTTP server. That's it. With 5 lines of code, I've written an HTTP server, and I didn't have to do a drag and drop. So I require the HTTP namespace, then I create the server. The HTTP server takes a method, a function, a callback, which takes 2 parameters, request and response. In the response, what I'm doing with this HTTP server is just saying, you know what, just spit out whatever. I don't care what the request is, always spit out the same thing, which is write head 200, write welcome to a simple HTTP server, and then end. And then I say to it, listen on port 5000, and now watch. I do console log server listening on port 5000. But watch what happens now. If I do node HTTP server listening on port 5000, and this doesn't terminate because now the event emitter isn't used internally, so it's waiting on an event, and it will never terminate until I explicitly terminate this process. So we can now open the browser, HTTP, yeah. No, the HTTP server is using it internally. Yeah. Yeah. No, you can have multiple event emitters, but the node knows that it has to wait for certain events, right? So for example, if you open a socket, it knows that it has to wait for a socket. If you open a file handle, it knows that it has to wait for a file handle. Okay? So welcome to HTTP server. Right? Done. Now that's silly. Let's go and take it one step higher. I've got a folder here that's called docs, right? And now I'm going to do a doc server. Now this isn't the way you would do it normally. It's not very efficient, but for now let's just leave it at that. So here I'm creating a HTTP server. Again, the same on request. URL parts. You see that I have a URL module which allows me to parse the URL, and I get the path name to know what doc I'm requesting. And now watch. Here's where the callback chain starts. I have path exists, right? So I say if the file exists, and this is the callback, then exists will return true if it exists and false if it does not. If it exists, then again with an asynchronous call, read file, and then if the file is read properly, write the head. If not, write something went wrong. If the file does not exist, write head 404 and end not found. At the end, I do listen 5000. So node http doc server. What's the name of the doc? Test.html. Okay, so we can come here and write test.html, and it will show me test.html. If I do tester.html, it will say not found. Okay, very simple. This is a proper way to implement that, because it doesn't load the contents into memory and shove it down. It uses this concept called a pipe, which basically interconnects the stream with the socket. Okay, so it reads it, buffers, and it prints it out. It's like if you're doing an internal buffering. Yeah. 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 That is done with that's all done for you. The next level to HTTP, you see, you didn't come to my session yesterday. Nope, there's your problem. I explained that in my session yesterday. So the next level to HTTP server is what's called connect, which is a module that starts to add a concept called middleware. And middleware allows you to intercept requests. And then you have caching, etc. And on top of that is express, which I'll show you now in a second. Okay? None of that has to be done manually. So .NET, the ecosystem, the Node Package Manager, as I said, it's like NuGet. I have a whole bunch of things done already for me. I have one which is a Socket.io library. Socket.io, if you're familiar with Signal R, are you familiar with Signal R? Signal R is a two-way communication library that you can use with ASP.NET. So basically it does push-pull from browser. Okay, you can do chat servers, etc. Socket.io is the equivalent. What Socket.io is a package for Node which allows you to do socket programming from browser to server. And what it does, it uses a fallback mechanism. So it will first try and see if the browser supports HTML5 WebSockets. If it does, it will use WebSockets. If it doesn't, it will fall back to trying to use Flash. If it doesn't, then it will fall back to trying to use HTTP polling using XML HTTP requests with AJAX polling, etc. So it takes care of abstracting socket communications for you and implementing it the way it can, right? It's a JavaScript package manager, so it works with Node. So here I have an example of a socket, IO, WebSocket clients. You can see that basically what I'm doing is this is the server. So I do require IO, require HTTP function URL, create the server. So this is just my HTTP server, and this is going to load an HTML page, which is going to be my client side. And then I have my socket server, which is socket.io, and I say on connection, emit a server message. So say to the server, send the message saying someone's connected. And then on client message, and these values I can define myself, I can say log the message and then broadcast it to all the other clients. All this is built in. So let's go over to the socket.io. Socket.io, and we'll do node websockets.js. And now I'll go over to the client, and now watch. The WebSocket client is just an HTML page, but it uses JavaScript as well, and it says create an instance of socket.io on server message, display it, and when I hit the submit button, send the message. Okay? So let's go over. What is the port? It's port 5000, yes. And it's called WebSocketClient.html. So I'll do WebSocketClient.html, and I get my thingy over here, and let me go and open up another one, and I've got two here. So I say hello, submit message, and here I should get the hello. How are you? Submit message, and here I should get the how are you. Okay? And the server is emitting the stuff that I told it to emit. Okay? So you can see that pretty much anything is already done. And for me to do that, you know what I had to do? I had to come to temp and I had to say make dir my chat server, cd my chat server, and then I do npm install socket.io. That's it. So now, just like NuGet, it will go to npsjs.org, fetch me all of the libraries it requires, find out all the dependencies it requires, get those dependencies, and I have that functionality now. And I can just create that web page and do socket.io. Okay? Much like this, what I can also do is, don't worry, that will eventually finish. Much like this, what I can also do is create a web framework. So you're familiar with ASP.NET MVC, right? So there is another framework that ASP.NET MVC was based off of Rails, right? Ruby on Rails. A lot of people in the Rails community, in the Ruby community, decided that Rails was too heavyweight, which it is, much like ASP.NET MVC now, and they decided to make another framework called Sinatra, right? Which is more lightweight. Now in .NET, there's also a version of Sinatra called Nancy, you know, Nancy Sinatra, and yes, I know. And then it's actually, yeah, you know who did it? A Swedish guy. Andreas. Anyway, the code junkie. Then there is, I'm giving this guy too much publicity every time. Right, so in Node, there's also the equivalent, which is Node. Node's version is called Express.js, right? And I'm going to show you now, I could do this in Macintosh and OS X, but I'm going to show you how to do it on Windows, because you get the exact same experience. And what we'll do is we're going to create, let me see if this gives me time. What I'm going to do is I'm going to create a Node.js application and try and push it up to Windows Azure, hosting it. Okay? For this, you need to install the Windows Azure SDK. So I'll do cd demos, make dir new Azure web, new Azure service, and we'll call it Nodu, cd Nodu. Oh, I'm already in Nodu. This new Azure service, this is a commandlet that I've installed. How much time do I have? Do I have 10 minutes? Good. This is a commandlet that this is a SDK for Node that you install from Microsoft. So when you install this, you get PowerShell. Everyone familiar with PowerShell? PowerShell, and it extends PowerShell with new services. So this is Glenn Block, the guy behind MEF and WCF Web API. He's now on the team that's developing this stuff. Okay? So I do Nodo, and now I do add Azure web role, so that will create a web role for me, right? And now what I'm going to do is I'm going to do npm install Express. Express is that framework that I was telling you about. Okay, so let's go ahead and create that framework. Now watch, this has created some files for me. One of them is called, no, this one was already created for me. Now what I've got to do is, Express actually doesn't do anything, it just installs the package. But there's an executable with Express which allows you to create a template, create an out-of-the-box experience already with routing and etc. Right? It's like an MVC framework. So I can do node bin express, and it'll say directory is not empty, you want to continue, done. Now I'll do npm install. What that does is it will get all the dependencies that Express uses at the same time, because Express is like an MVC framework. So you have a model, you have a view, Jade is the view engine. Now watch here, I have a file called app.js. Okay, bear with me a second, I will delete that app. Sorry, I'm going to delete server.js, and then I'm going to rename app to server.js. Okay, now if you look at server.js, this is a Node application. This is an Express.js application, right? So if I actually run this now, I have an application locally, and I'll show you in a moment. But what I'm going to do is, because this will give an error on Node, because here it's telling you what port to listen to. When you deploy to Azure, you can't select the port. So I just say to use the environment port that the process is running on. Okay? Now watch. If I do node server.js, see that that's running. I can open up a browser and I can do HTTP. Actually, I don't know what it's going to run on now, so hold on, where am I? I'll put 3000 and then 3000 or the port that's available. Node.js, open up the browser and do HTTP 3000, and I have welcome to Express. Okay, so that's a whole, I don't have time to go through this, but basically this is create a whole infrastructure with a folder called views, where I have my view pages, where I have my routing, etc. You can examine that later. Right, now switch back here. We'll examine it as I publish, and now I can do publish Azure service, and I'll give it a name. I'll call it Node.hh. Name. Done. Okay, so that's now going to publish this to Windows Azure. So when I open up Windows Azure, we can come back here. It takes about 10 minutes, so that gives me time to talk another 5 minutes. And if I go to Azure, windows.azure.com, this is my interface to my hosted instances on Azure. You can see that this, I have some demos from before. Do I still have 5 minutes? Really? Wow. Oh yes, I do. Okay, so I can slow down a little bit now. Whew. Right, so you can see that I have hosted services, and you see this Node.uhh? That's being pushed up. Why did I put this weird name? Because once this is done, it's going to have the domain name is going to be, you can see here, for instance, oh, I've stopped that. It would be nodeuhh.cloudapp.net. Okay, so it has to be a unique DNS name. So no one suffixes their stuff with HH because that's my initials. So this is now created and it's still working. If we go back to Windows, you can see that it's still working. Now this takes about 10 minutes. Okay, while this is working, we'll hope that it will finish before the session is over. If we go and we can examine what I've done. When I downloaded the Express package, that's a web framework package, right? And when I created that application, it created for me some folders. It created a public folder with images, JavaScript, style sheets, much like ASP.NET MVC. It created views, which it uses Jade. Jade is a templating language, which is like HTML without the angle brackets. Okay, and it also created for me some JavaScript. So if I open this guy, you can see that basically I have my root. It says when index is called, process it by calling response render index. Render is to render a view, and I can pass in the name of the view and then data. This would be the equivalent to the view model. And the server file is where it actually delegates to that index. So you see this, it requires Express, it sets up the server. This is those middlewares, right? The middleware I was talking to you about. If I want to do caching, I would do app use and then connect.cache. There's a module for that, for instance. What do you mean? No, because this is still single-threaded. Yes, you can rest assured that this is always single-threaded. Then this is to configure the different environments, and now you see that instead of me having a function request response processing, in Express.js what that adds is verbs. So I can now say get, post, put, delete, and then pass in the root, and then give it a function to call, right? So it's already added so much for us. We don't have to do any of that HTTP server, loading files, all of that by hand. Express.js does that. I had a session yesterday, full session on Express.js. If anyone wants the slides and the demos, I'm more than happy to give it to you if you couldn't come. Okay, so this will continue, and maybe until I do questions and answers it will finish. If not, I'll leave it running, and if you eventually go to nodeuhh.cloudapp.net, you will see that instance working with the exact same message, which is welcome to Express. Okay, but what I wanted to show you there is how easy it is to that experience of write my application and push it to the cloud. Very simple. Okay, It's the exact same application I just pushed. Node on IIS, basically it's using IIS Node, so it's an implementation of Node, not on the self-executable, but on IIS. So you have the advantage of interacting with IIS as well. Node on Azure, as what is exactly what I just showed you. So it requires the Azure SDK to be installed, and then you have to get your publishing settings, which you can do and just install them locally on your machine. You have two ways to do Node on Azure is web role or worker role. Web role is using IIS. Okay. Takeaways. The fallacy of everyone knows JavaScript, and this is important. Not everyone knows JavaScript, and if you look through the npm packages on there, there is absolute rubbish written with JavaScript, right? People knew how to do copy and paste with JavaScript, but to create maintainable systems, you need to learn, embrace what JavaScript offers you, and do things properly. But unfortunately, the what we call the hipster JavaScript web devs of today, right, with their pants until here, no JavaScript. I hope no one has their pants until here that I offended. No, you can have your pants until wherever you want. It's not for intensive CPU processes, because if all the time I'm spending with Node is doing CPU processing, then it's of no use, because I'm blocking the thread, right? If I want to do that, I could do a threaded solution of Node. Then you start to question, why am I doing that? It's great for real-time apps, servers, etc. No, don't jump in for the sake of it. That's what I wanted to say. Come on. This is the bad thing about this timing theme, because now I have to go through it again. Don't just jump into Node for the sake of it. Evaluate it, play with it, try it, but don't do it. And don't follow the Church of Technology fashion, right? And if you don't know what that is, watch that video. Okay? It's one of these videos which, you know, the two little, what are they called? Node is badass rockstar technology. Okay, watch it, because it's got some very good points. It's talking about, you know, why I'm just using Node for the sake of it. No, don't jump on board this train just for jumping on board. Let me see if this is finished. Nope, it's still not finished. But as you can see, it's doing more things here. You see, now it's initializing, starting, etc. As soon as you guys get up and leave and close and say, you know, bye-bye, I'm going to go and have lunch, which I know I'm keeping you from, that will end. Okay, so I will let you go. That is my email address, hadi@jetbrains.com. That is my Twitter. If you have any questions, I think you can tweet or hook up with me later. I'll be here for another hour and then I got to leave, or email me later. Okay, thank you very much.